Good morning, ladies and gentlemen. How are you going today? Hopefully you've had a good weekend. Today we're going to look at something called prime decomposition. So our title for today is prime decomposition. So write down the title please in your rulebook. Sometimes textbooks might call it prime factor trees. So prime decomposition combines the two topics which we looked at last week, which is, first of all, we looked at prime numbers. So recall from last week, prime numbers were numbers which only had factors of 1 at itself. Now 2 is our first prime number. Remember, 0 and 1 are not prime numbers. 2 is a prime number. Our next prime number is 3. 4 is not a prime number because 4 has 3 factors, namely 1, 2, and 4. So prime numbers only have 2 factors, 1 in itself. So our next prime number is 5, and then 7, not 9 because 3 times 3 is 9, so 3 is an extra factor, and then 11, etc. So we looked at that last week. We also looked at last week the use of indices or powers to show repeated multiplication. So we also said, for example, 2 to the 5 is 2 times itself 5 times. So 2 times 2 times 2 times 2 times 2. So that was index notation. So today in prime decomposition, we're really combining these two ideas together. So let's start off with a definition. So all composite numbers, so remember a number is either prime or composite, except 0 and 1 because they're special. So a composite number are those who have more than 2 factors, so which are not prime. So composite numbers can be decomposed, or in other words, broken down into a unique, so a special set of prime numbers. And we use this technique called a factor tree. So use factor trees to get these special answers.